Good morning once again, folks. This is Mike with another video on college algebra. In this video, we are going to talk about a different type of conic section. We are going to talk about hyperbolas. So getting a little bit of a visual of it and how it is a conic section. If we take a look at our image here on the left, we have our typical two-sided typical cone. Typically, we think of a cone as being only one thing here, but the whole conic section is actually two. In previous videos, we talked about circles and ellipses. A circle you get as a result of taking a plane, let's say like a flat piece of paper, and you chop it horizontally through the cone here. That gets you a circle. If you take that plane or that piece of paper and you chop it through the cone at a slight angle, you get an ellipse. Well, if you take that plane and you chop it vertically through the cone, you get what's known as a hyperbola. So where we have these curves here, where the plane and the cone intersect, that is our hyperbola. But what is the actual definition of a hyperbola? It's the set of all ordered pairs or all points x comma y in a plane such that the difference in distances between x comma y and two fixed points called the foci is a positive constant. So we have distance from x comma y to one focus, and then distance from x comma y to the other focus. If we take the difference of those two distances, if that difference is equal to some particular constant, then that point lies on the given hyperbola. And what is this distance? The distance has to equal 2a. In a little bit, we're going to see where that a comes in. Each hyperbola consists of two branches. The points where the hyperbola intersects the line passing through the foci are called the vertices. The line segment between the vertices is called the transverse axis, and the midpoint of the transverse axis is called the center. Now, unlike ellipses, where the foci sort of lie inside of our shape, when it comes to hyperbolas, the foci lie outside the shape. And I put the outside sort of in air quotes. We'll see here very shortly. Hyperbolas can look like one of the two shapes here. These are not perfect drawings by any means. These are just rough sketches. You're not being graded on your artwork in this course, so don't grade me on mine. So here, the point. So these here are the vertices. The foci are going to lie somewhere outside, and again I put in air quotes, outside the two branches here. If you think of what's in here as inside, these out here, those are outside. So the line segment through these foci, that line segment intersects the hyperbola itself at 2 points. Those points are the vertices. I'll put those with V's. Here the F's are the foci. This line segment here between the vertices, that's your transverse axis. And then the midpoint of the transverse axis, aka the midpoint of your vertices, is the center. And I'll call that C. That is the center of your hyperbola. This is where we have a vertical transverse axis. The other type of thing we could see is a horizontal transverse axis. In this case, your foci are going to be somewhere out to the sides, somewhere to the left of this branch and to the right of that branch. Again, picture this line going between the foci. That line segment intersects the hyperbola in 2 points. Those are the vertices. Here's your transverse axis, and then that point there in the middle is called your center. Now, in each of these cases, these are sort of the nicest cases we can have, where the center lies at the origin, or the point 0, 0. That's not always going to be the case. The center could certainly occur at any point here, and we can have all different kinds of things happening with our vertices and our foci. So we're going to talk about the general formulas, or the general equations for hyperbolas, and sort of seeing all the things that we could have. So, assuming A and B are both positive quantities, we have a little bit of a difference in the equation for our hyperbola based on whether the transverse axis is vertical or horizontal. If it's horizontal, it's of the form x minus h squared over a squared minus y minus k squared over b squared is equal to 1. If the transverse axis is vertical, it's y minus k squared over a squared minus x minus h squared over b squared is equal to 1. So this is different from the ellipses that we talked about in our previous video or two. Whether the major axis for an ellipse was horizontal or vertical, the a squareds and the b squareds changed places, and there was a plus here. When it comes to hyperbolas, whether the transverse axis is horizontal or vertical, the x minus h and the y minus k, those things change places here, and now instead of a plus in the middle, we have a minus. So very, very important to keep in mind when we compare equations for hyperbolas. Just like with ellipses, though, the center point, regardless, always has the form h comma k. The foci, if you have a horizontal transverse axis, it's h plus or minus c comma k. If your transverse axis is vertical, it's h comma k plus or minus c. The vertices, horizontal transverse axis, h plus or minus a comma k. If it's vertical, h comma k plus or minus a. And the asymptotes. We are vaguely familiar with the concepts of asymptotes going a little bit further back in the course, going all the way back to chapter 3. These dashed lines here, where the branches get super close to but never actually touch. In each of these cases, there are equations for these dashed lines, and they serve as our asymptotes for the hyperbola. If you have a horizontal transverse axis, the point slope form for the asymptotes for your hyperbola is y minus k equals plus or minus b over a times the quantity x minus h. So 2 lines we get here. The only thing that differs really is their slope. They have opposite sign slopes. If you have a vertical transverse axis, then it's y minus k equals plus or minus a over b times the quantity x minus h. So if you're given the equation for a hyperbola, you should be able to identify key features of said hyperbola: the center, the vertices, the foci, and the equations for the asymptotes. So here, first one, x minus 3 squared over 9 minus y squared over 16 is equal to 1. We need to identify the center, vertices, foci, and equations for the asymptotes. So just looking at the equation that we have right here, we have the x term listed first and the y term listed second. If the x term is listed first, like it is here, then we know that this thing has to have a transverse axis that is horizontal. So that's something we can just note here. Transverse axis horizontal. Okay, let's actually get into some of the key bits and pieces of information that we're going to need. We are going to need the center. We are going to need the foci. We are going to need the vertices. And we are going to need the asymptotes. All right, ASYMP for short. Again, looking at the general formula here, it's a squared on the bottom and then b squared on the bottom. A squared on the bottom of the first fraction, b squared on the bottom of the second. So comparing that to what we have here, 9 is my a squared and 16 is my b squared. So I can easily figure out what my a and b values are going to be. The square root of 9 is 3. Square root of 16 is 4. And again, a and b are positive, so we're taking the positive square roots here. Now, the other thing that we're going to need when it comes to coming up with our key pieces of information, we have our a value, we have our b value, we have h's and k's. That's coming from our center, which we'll find very shortly. The other thing we're going to need is our c value. Well, c is sort of dictated by this relationship here. C squared is going to equal a squared plus b squared. So to find my c value, all I have to do, square each of these things, take that sum, and then take the square root of that sum. So c is going to equal the square root of 3 squared, 9, plus b squared, 16. And the square root of 9 plus 16, or the square root of 25, is equal to 5. So there we go. We have our c value. All we need to figure everything else out are the h and the k value. So let's figure those things out first. That will get us our center, and then we can figure everything else out. So again, x minus h, y minus k. If you're seeing minuses in here, or if you're seeing a minus in here, then that value is going to be positive in your center point. If you're seeing a plus in here, then that coordinate of your center point is going to be negative. So here we have x minus 3. So x minus h, x minus 3. My h value, the x coordinate of my center point, is 3. Here we just have y squared. Well, this is saying the same thing as y minus 0 squared. So y minus 0 squared, y minus k squared. comparing those two, k has to equal 0. So now we have all the pieces of information that we need to figure out the other three key pieces of info, the foci, the vertices, and the equations for the asymptotes. So let's calculate the foci. This is a hyperbola, as we said, that has a horizontal transverse axis. So I got to work with this formula right here and down this column here. The foci are going to have coordinates h, 3, plus or minus my c value, and we calculated our c value to be 5, comma, k, my k value being 0. So if I do 3 plus 5, that gets me 8. And if I do 3 minus 5, that gets me negative 2. So these are my foci, 8 comma 0 and negative 2 comma 0. The vertices, formula for the vertices, h plus or minus a comma k. So again, h value of 3 plus or minus, we found that the a value itself was 3, comma 0. So if I do 3 plus 3, that gives me 6 comma 0. If I do 3 minus 3, that gives me 0 comma 0. And lastly, the equations for the asymptotes. We have y minus k. Here the k value is 0. Equals plus or minus. Now it's b over a, so 4 over 3 times x minus my h value, x minus 3. So we can write these out as two separate lines. Y equals plus 4/3 times x minus 3, or y equals minus 4/3 times x minus 3. So these are the equations for our two asymptotes, and this is all of the key pieces of information that we need for our hyperbola given the equation. Moving on to the next problem, we're going to do the same thing, but in this case, the equation is y plus 1 squared over 25 minus x minus 6 squared over 4, and that's equal to 1. Looking at this one, we see we have the y's being listed first. The x's are in the second fraction. Comparing that to the general formulas here, if the y term is being listed first, then we have a vertical transverse axis. So we're going to make a note of that. Transverse axis, vertical. So again, we're going to need the center. We're going to need the foci. We're going to need the vertices. And then we're going to need the equations for the asymptotes. Well, again, comparing the general formula, y minus k, x minus h. The center is still h comma k, as we see here. So looking at our particular hyperbola here, excuse me, we have y plus 1 Now, if it was y minus 1, then the y-coordinate of our center would be positive 1. But here it's y plus 1, so that means the y-coordinate of my center is going to be negative 1. And then here the x-coordinate of our center, x minus h, x minus 6. So comparing those, h has to be 6. All right, again, looking back, it's still a squared first and then b squared second on the bottoms of our two fractions. So doing that, a squared is equal to 25, which means a is 5. B squared is 4, which means b is equal to 2. And then we use this formula right here to figure out what c is. We take the square root of the sum of the squares of these two things, or just the square root of the sum of these two numbers, because these are a squared and b squared. So c is going to equal the square root of 25 plus 4, and that's equal to the square root of 29. All right, so we have our a, b, and c values, we have our h, we have our k, we can figure out all the other pieces of information that we need. The foci, again, it's a vertical transverse axis, so we need to work in this column here. The foci take on the form h, comma, k plus or minus c. So h, 6, comma, negative 1 plus or minus my c value, which in this case is equal to the square root of 29. Now, when it comes to writing this answer out, if you leave your final answer like this on a handwritten quiz or test, this is absolutely perfectly fine. You don't have to write out the two separate points here. You know, this would give you full credit, certainly. But when submitting a problem online using Connect Math, they may want you to type out the two separate points. That's just something you just sort of have to figure out. But I'll write the two separate points here as well. Six comma negative 1 plus the square root of 29, and 6 comma negative 1 minus the square root of 29. All right, the vertices take on the form h comma k plus or minus a. So 6 comma negative 1 plus or minus my a value of 5. And this one's not too bad to write out two separate points for. If I do negative 1 plus 5, that gives me 4. If I do negative 1 minus 5, that gives me negative 6. So 6 comma 4 and 6 comma negative 6. And then the equations for the asymptotes, y minus k, again, equals plus or minus. Now it's a over b, not b over a, and then times that quantity, x minus h. So y minus the negative 1, or plus 1, equals plus or minus. Again, now we said it's a over b, not b over a. So it's going to be plus or minus 5 halves times the quantity x minus 6. And once more, if this were being handwritten on a quiz or test, leaving your final answer like that would be perfectly fine. You would receive full credit. But if you're submitting a problem through Connect Math, they may be a bit more picky. They may want each line written out separately. They also may want these lines in slope intercept form as well. So those are just some things you have to keep in mind that you could have to do, but an answer like this, handwritten on a test, would be perfectly fine. So guys, this is the first kind of problem you should be able to do. If you're given the equation for a particular hyperbola, you should be able to identify the key features of it. The center, vertices, foci, and equations for the asymptotes. So we'll stop here for now. In our next video, we are going to talk about the other types of problems that you should know how to solve that pertain to hyperbolas. If you guys have any other questions or comments, please be sure to reach out to me, guys. Email, text, voicemail, letters, messages tied to carrier pigeons, signs in the sky, whatever you have to do. Until the next video, take it easy, guys.